our previous lecture, we studied about different clustering techniques. In this class, we will start a new topic, that is a classification and regression trees. Shortly, this is called CART models. The agenda for this lecture is Introduction to Classification Regression Trees, Attribute Selection Measures and Introduction. There are different measures for selecting attributes. Attributes means variables, that we will study about different attribute selection measures in this class. The introduction about this topic, CART model. Classification is one form of data analysis that can be used to extract models describing important data classes or to predict future data trends. Classification predicts categorical, that is discrete unordered labels, whereas regression analysis, a statistical methodology that is most often used for numeric prediction. There is a difference between classification techniques and regressions. In classification techniques, the dependent variable is categorical variable most of the time, but in a regression analysis, most of the time the regression analysis, the continuous variable is the dependent variable for regression analysis. For example, we can build a classification model to categorize the bank loan applications as either safe or risky. See, this is categorical. The regression model is used to predict expenditures in dollars of potential customers on computer equipment given their income and occupations. Most of the time, the regression analysis is used to predict a continuous variable, but the classification analysis is used to predict the categorical variable. We are going to take one problem. This problem is taken from this book, Hahn, Pei and Comber, Data Mining. Book title is Data Mining Concept and Techniques. The problem says there are 1, 2, 3, 4, 5 columns. The 5 columns, there is age is there, income is there, student, credit rating. This dependent variable is Bayes computer, Bayes underscore computer. So, this is a database, one portion of database is shown. So, the dependent variable is Bayes computer. There are 4 independent variables like age, income, student and credit rating. So, by taking this example, we are going to explain how to use CART model. In coming lecture also we will use this data. Now, let us understand certain terminology in the CART model. For example, root node, internal node and child node. When you look at this picture, there is age, there are 3 levels, youth, middle aged, senior. Then it is student, there are 2 levels, no or yes. Credit rating, there are 2 levels, fair and excellent. So, a decision tree uses a tree structure to represent a number of possible decision paths and an outcome for each path. The decision tree consists of root node, internal node and leaf node. You look at this, the first one, the age, because the whole problem we are going to start with the variable age. So, this age is called root node or parent node, that is in the rectangular box. A decision tree consists of root node, internal node and leaf node. The topmost node in a tree is called root node or parent node, this one, for example age, this is a root node. It represents entire sample population. The next term is internal node. For example, here student is the internal node, or non-leaf node denotes a test on an attribute. Each branch represents outcome of the test. The next node is leaf node or child node. See this yes or no, that is which is in the elliptical shape, that is called a leaf node. It cannot be further split. A decision tree for the concept Bayes computer is a variable indicating whether a customer at all electronics, that is a database where it was taken, a customer at all electronics is likely to purchase a computer. Each internal node represents a test on an attribute, each leaf node represents a class. A class means either a person buys a computer, yes or no. Actually this yes or no is nothing but this column that will go to into the child node. Now The CART comes under supervised learning techniques. We know that the machine learning techniques are classified into two categories. One is supervised, another one is unsupervised. What is the meaning of supervised learning is that there is a label. Label in the sense we know in advance what is going to be independent variable, what is going to be dependent variable. In this problem also it is supervised learning because we know in advance what is the BICE underscore computer is going to be our dependent variable. Then CART adopts a greedy, that is a non-backtracking approach in which decision trees are constructed in a top-down recursive divide and conquer manner. It is very interpretable model. A person who is not having any statistical analysis also can easily interpret the CART model. Now I will explain the decision tree algorithm. What are the inputs? Data partition D, this whole data set is a set of training tuples and their associated class labels. This is the class labels. Attribute list is the set of candidate attributes. For example, in this problem these are the attributes: age, income, student, credit rating. Now what we have to do before starting the problem, out of these 4 variables we have to decide from which variable we have to start for classification. So for that we need a attribute selection method. So attribute selection method, a procedure to determine the splitting criterion that best partitions the data tuples into individual classes. This criterion consists of a splitting the attribute and possibly either a split point or splitting subset. So the output of this model will be the decision tree. Decision tree algorithm. The algorithm is called with the 3 parameters. One is D, that is a data set, then is attribute list, independent variable, and attribute selection methods. D is defined as data partition. Initially it is the complete set of training tuples and their associated class labels. In our problem this whole table represents the D. Initially what is that? It covers all the independent variables and dependent variables. The parameter attribute list is a list of attributes or independent variables which are describing the tuples. Here the parametric attributes nothing but all the independent variables. So attribute selection method specify a heuristic procedure for selecting the attribute that best discriminates the given tuples according to class. This procedure employs an attribute selection measures such as information gain, that is the one method for selecting the attribute. Second one method is called gain ratio. Third method is called Gini Index. Whether the tree is strictly binary is generally driven by the attribute selection measures. For example, we can go for binary selection. Suppose this is one variable. Sometimes we can go for more than 2 classification also. For example, if you use Gini method that we will cover in coming class, that always you need to go for binary selection. Some attribute selection measures such as Gini Index enforce the resulting tree to be binary. Others like information gain do not, therein allowing multi-way splits. So if you follow Gini Index there is only binary split. If you follow other than Gini Index, for example information gain, you can have more than 2 split also. Decision tree method. I am going to explain different steps in the decision tree method. There are 15 steps. In coming slides I have explained in each steps. So first we will start the overview of all 15 steps. Create a node n. If tuples in D all are of the same class C, then return n as the leaf node labeled with the class C. If attribute list is empty, then return n as a leaf node labeled with majority class in D by using the concept called majority voting. Then apply attribute selection method D to find the best splitting criterion. Label node n with the splitting criterion. If splitting attribute is discrete valued and multi-way splits is allowed, then attribute list, there are different attribute list that we can choose. For example, splitting attribute is one method. The step 8 is if splitting attribute is discrete valued and multi-way split is allowed, then the attribute list which already have occurred, that has to be removed from our D. For each outcome j for splitting criterion, so what is the splitting criterion is partition of the tuples and grow subtree for each partition. Let dj be the set of data tuples in D satisfying the outcome j. If dj is empty, then attach a leaf labeled with the majority class in D to node n. Else attach node returned by generate decision tree to node n, then n for return n. So I am going to explain that each steps in detail in coming slides. The tree starts as a single node n representing training tuples in D. That was our step 1. If the tuples in D are all of the same class, then n becomes a leaf and is labeled with that class. That is step 2 and 3. If the tuples in D all are the same class C, then return n as a leaf node labeled with the class C. The meaning is, suppose the age is taken as variable. If there are 3 split, one is youth, middle aged and senior. For example, the middle aged with respect to our dependent variable, all are answered yes. So if it all are answered yes, we need not go for further classification. Then the age attribute has to be dropped from our model, then we have to continue with the remaining attributes like student, credit rating and income. So step 4 and 5 are terminating conditions. If attribute list is empty, that means you have to go for each attributes. Otherwise, the algorithm calls attribute selection method to determine splitting criterion. Suppose only one attribute is there. If there are remaining attributes, to choose that attribute, you have to use attribute selection method to determine the splitting criterion. The splitting criterion, like Gini, tells us which attribute to test at node n by determining the best way to separate or partition the tuples in D into individual classes. The splitting criterion indicates the splitting attributes and may also indicate either a split pointer or splitting subset. I will explain what is the meaning of split point and splitting subset in next slide. The splitting criterion is determined so that ideally the resulting partitions at each branch are as pure as possible. A partition is pure if all of the tuples in it belongs to the same class. The node n is labeled with the splitting criterion, which serves as a test at the node, that is step 7. A branch is grown from node n for each of the outcomes for splitting criterion. The tuples in D are partitions accordingly. That is our step 11. So 3 possibilities for partitioning tuples based on the splitting criterion. There are 3 possible scenarios as illustrated in figure A, B and C. Let A be the splitting attributes. A has V distinct values A1, see A1, A2 and AV based on training data. If A is discrete valued in figure A, then one branch is grown for each known value of A. See, for example, color may be red, green, blue, purple, orange. If it is income, there are 3 split, low, medium, high. If A is a continuous valued in figure B, then 2 branches are grown corresponding to A less than or equal to split point and A greater than or equal to split point. So what will happen? The A less than or equal to split point is the one split, A greater than split point is another branch, where the split point is the split point returned by attribute selection method as part of the splitting criterion. For example, income is there. We can group that into 2 categories, those whose incomes are below 42,000, those whose incomes are above 42,000. This 42,000 generally is nothing but the average value. If A is a discrete valued and binary tree B must be produced, then the test is of the firm A belongs to SA, where SA is the splitting subset of A. So you see that A belongs to SA. If it is yes, is one group, no if it is another group. If A, for example, color, it may be red or green, then that time also it should be yes or no. Then we will go for termination condition. The algorithm uses the same process recursively to form a decision tree for the tuples at each resulting partition dj of d. What is the recursion means? If one attribute is over, that is repeated for the second attribute and third attribute up to all the attributes are exhausted. The recursive partitioning stops only when any one of the following terminating conditions is true. The first condition is all of the tuples in partition D representing at node n belong to the same class. That was we are saying step 2 and 3, or there are no remaining attributes on which the tuples may be further partitioned, that is explained in step 4. In this case, majority voting is employed. This involves converting a node into a leaf and labeling it with the most common class in D. Alternatively, the class distribution of the node tuples may be stored. The third condition is there are no tuples for a given branch, that is a partition dj is empty, that is explained in step 12. In this case, a leaf is created with the majority class in D, that is our step 13. The resulting decision tree is returned, that is our step 15. Now, the second part of this lecture is different attribute selection measures. Attribute selection measures are also known as splitting rules because they determine how the tuples at a given node to be split. It is a heuristic approach for selecting the splitting criterion that best separates a given data partition D of class labeled training tuples into individual classes. The attribute selection measures provides a ranking for each attributes describing the given training tuples. The attributes having the best score for the measure is chosen as the splitting attribute for the given tuples. If the splitting attribute is continuous valued, or if you are restricted to binary trees, then respectively either a split point or split subset must also be determined as part of the splitting criterion. There are three popular attribute selection measures. One is information gain, gain ratio, Gini index. In this class, I am going to explain the theory about these three attribute measures. In coming classes, by using the same examples which I have discussed, I am going to find out the value of information gain. I am going to explain the selection procedures using the criteria information gain, gain ratio and Gini index. So, in this lecture just we are going to see the theoretical point of all these three selection methods. So, CART algorithm uses information gain and Gini index measures for attribute selection. Attribute selection measures, let us find out certain notations. The notation used in herein is as follows: let D the data partitions be a training set of class labeled tuples, for example this data set. Suppose the class label attribute has m distinct values. Here m is this is the class 1. Here the value of m is 2 because S is one category, no is another category. Distinct class in Ci. The Ci is, it is 1 to m, it may be 1, in another name it is 2. Let Cid be the set of tuples of class Ci in D. For example, what is the Cid means? For example, if it is high for its income variable, in high how many no is there? 1, 2, high it is a 2. For income one level is called high, for that it is no. So, that is our Cid. Cid set of tuples of class Ci in D. So, this modulus of D represents that the 14, Cid represents how many number of values, if it is high and what is no. If it is, for example, if you say low, this variable income variable low, how many yes is there? 1, low, 2, low, 3. So, 3, the modulus of Cid is 3. So, these values I have explained in coming lectures with an example. Then we will go to the first criteria for selecting the attributes, information gain. This measure studied the value or information content of messages. The attribute with the highest information gain is chosen as the splitting attribute for node. This attribute minimizes the information needed to classify the tuples in the resulting partitions and reflect the least randomness or impurity in these partitions. So, this approach minimizes the expected number of tests needed to classify a given tuple. So, information gain, that is nothing but entropy measure. The expected information needed to classify a tuple in D is given by info D equal to minus summation I equal to 1 to m pi log pi to the base 2, where pi is the probability that an arbitrary tuple in D belongs to class Ci and is estimated by modulus of Cid divided by modulus of D. For example, in this, for this data set, what is a pi? Pi is the number of s. How many number of s is there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So, it is 9. That 9 is nothing but our CID. The modulus of D is total 14. That is for level 1. If for the level 2, how many no is there? 1, 2, 3, 4, 5. So, 5 divided by 14 log 5 divided by 14 to the base 2 equal to 0.940 bits. So, this is the meaning of our info D. A log function to the base 2 is used because the information is encoded in bits. So, info D or entropy, another name for entropy, is just the average amount of information needed to identify the class label of a tuple in D. Generally, the lesser the value of entropy, that means we need very less information to identify the class label of a tuple D. So, generally the value of entropy should be less, so that attribute will be chosen for classification. It is quite likely that the partitions will be impure, where a partition may contain a collection of tuples from different classes rather than from the single class. So, how much more information would still need after the partition in order to arrive an exact classification? So, this amount is measured by info D for one attribute, that is for summation j equal to 1 to v for all the splits, modulus of dj divided by modulus of d multiplied by info dj. This is nothing but your entropy. The term dj modulus dj divided by modulus d act as a weight of jth operation. Info d for attribute A is expected information required, this one, expected information required to classify a tuple from D based on the partitioning by A. So, the information gain, the smaller the expected information required, the greater the purity of the partitions. So, information gain is defined as the difference between the original information requirement, that is done by based on just proportion of classes, and the new requirement, that is obtained after partitioning on A. So, the gain A is info D minus info D for attribute A. I have used this example in my coming classes. With the help of numerical example, I have explained how to find out the gain A. The attribute A with the highest information gain is chosen as a splitting attribute at node n. You see that the entropy should be very smaller, but the information gain should be higher for choosing an attribute. Next, we will go to the next concept, Gini Index. Gini Index is used to measure the impurity of D. A data partition or set of training tuples. The formula for Gini D is 1 minus sigma of I equal to 1 to m pi square, where pi is the probability that tuples in D belongs to a class Ci and is estimated by modulus of CID divided by D. For example, I will explain for this data set how to find out Gini index. So 1 minus, so how many S is there here? It is 9 S is there, so 9 by 14 whole square, minus how many no is there? 5 no is there, 5 divided by 14 whole square. So 1 minus 9 minus 4 14 whole square minus 5 by 14 whole square is equal to 0.459. This is Gini index. Because the sum is computed over m classes, we are doing for all the, for m equal to 1, m equal to 2. The Gini index considers a binary split for each attribute. So here we are going to get only binary split if you use Gini index. When considering a binary split, we compute a weighted sum of impurity of each resulting partitions. For example, if you binary split on a partitions D into two category, one is D1, D2, then the Gini index of D given that partitioning is, so Gini D for each attribute, modulus of D1 divided by D, Gini of D1 plus modulus of D2 divided by modulus of D, Gini of D2. So in my coming lectures, I have used this formula also with the help of a numerical example. There you can have very clear understanding how we are finding this. For each attribute, each of the possible binary split is considered. For a discrete valued attribute, the subset that gives the minimum Gini index, you have to remember this, minimum Gini index for that attribute is selected as its splitting subset. For continuous valued attributes, each possible split point must be considered. The strategy is similar where the midpoint between each of the pair adjacent value is taken as a possible split point. If there is a continuous variable, the midpoint in a sorted data set, the midpoint should be taken as the splitting criteria. For a possible split of A, D1 is the set of tuples in D satisfying A less than or equal to split point, and D2 is the set of tuples in D satisfying A greater than split point. The reduction in impurity that would be incurred by a binary split on a discrete or continuous valued attribute A is delta of Gini A equal to Gini D, this is for our class variable, minus Gini D for a particular attributes. The attribute that maximizes the reduction in impurity has the otherwise, which is having minimum Gini index, is selected for splitting attributes. So this value should be maximum, otherwise this will maximum only if the Gini index is minimum. So we have seen two methods. One method is information gain, another method is Gini index. There is one more method is called gain ratio that I will take in my coming classes. So how to choose which attribute method has to be chosen? All measures have some bias. For example, this technique information gain also having some bias that I will explain coming class. The time complexity of decision tree generally increases exponentially with the tree height. Hence, measures that tend to produce shallower trees, that is with a multi-way rather than binary split, and that favor more balanced split may be preferred. That is why most of the time Gini index is chosen, because that is giving a balanced split. However, some studies have found that shallow trees tend to have a large number of leaves and higher error rates. Several comparative studies suggest no one attribute selection measures has been found to be significantly superior to others. Next we will go to the concept called tree pruning. When a decision tree is built, many of the branches will reflect anomalies in the training data due to noise or outliers. So tree pruning uses statistical measures to remove the least branches. Pruned trees tend to be smaller and less complex and thus easier to comprehend. They are usually faster and better at correctly classifying independent test data than unpruned trees. How does tree pruning work? There are two common approaches to tree pruning. One is pre-pruning, another one is post-pruning. In the pre-pruning approach, the tree is pruned by halting its construction early. That is, by deciding not to further split or partition the subset of training tuples at a given node. When constructing a tree, measures such as statistical significance, information gain, Gini index can be used to assess the goodness of a fit. Now let us talk about the post pruning. The post pruning approach removes the subtree from a fully grown tree. A subtree at a given node is pruned by removing its branches and replacing it with a leaf. The leaf is labeled with the most frequent class among the subtree being replaced. Look at this picture which is given in the next slide. Assume that we are going to remove these portions. What is happening? In this, when you look at this one, if you are removing this portion of the tree, the class B is frequently occurring. So we have to bring as a leaf node. In that leaf node, the class B has to be retained. For example, the subtree at the node A3 in the unpruned tree is shown in figure 1.2. The most common class within this subtree is class B. Look at this. There are class B is there, class B is there, class A is there, one class A is there, two class B is there. So the most common class with this subclass is class B. In the pruned version of the tree, the subtree in the question is pruned by replacing with the leaf class B. You see that this is the pruned version, in that we have retained class B. This figure explains unpruned decision tree and a post pruned decision tree. What I have done in this lecture, I have introduced what is classification regression tree CART model. Then I have explained different terminology which are frequently used in the CART model. Then I have explained the theory behind different attribute selection measures like information gain, Gini index. At the end, I have explained how to do the pruning of the tree. The next class, with the help of a numerical example, I will explain how to do or how to select different attributes. For example, with the help of information, how to choose attributes, correct attributes. Thank you very much.